So the first one here is the Mathematics Resource Center. That is the standard. It's a free online and in person. It's provided by the department, the mathematics department, and it's provided for students in mathematics course. Okay, so the information you can find here, so I provided here, and is the red for this center. So if you have any question or concerns about the mathematics, not just about elementary statistics, you have a question about the calculus one, you have about elementary function, something like this. So you can go to this center and you can ask the tutor there. I am also work in this center. So you can meet me on Tuesday and Thursday if you have any question. Okay, that's all the things about the Mathematics Resource Center. Okay, any questions about this? No? Okay, hope you find it useful here. Okay. Hi. Okay, so this okay, let me tell you something about the assignment this week. Okay, first, as you can see on canvas here, so you have some statistics online homework, 4.1, 4.2, and 4.3. So that will be in this week. Okay, 4.4 and 5.1 this is next week, and some interactive review here. Interactive review in this week is 4.1 to 4.5. Okay, and now we go to the complicated material. It's the probabilities material. So when you finish today, so you will finish 4.1, and I recommend you should go to the online homework as soon as possible to do 4.1. Okay, this will help you to understand the material and push your memory about the material in class. Okay, so this is very crucial. Okay, when you finish for each section, so you should go to the online homework and do as soon as possible. Because this chapter is very easy to make mistake in this chapter and the next chapter. Because it have a lot of computation. Okay, so you need to practice more and more. Okay, that is the thing. When I saw the chapter, this chapter. Okay. Okay, now if you have any concerns about the first exam, so you can ask me at the end of the class. Okay. So now I will talk about. I will move on to this chapter 4. Chapter 4 is talked about the probabilities. Okay, probabilities. Okay. So the objective of this chapter here is identify the sample space of probability event, and you will have three kinds of probabilities. With three kinds of probability, it's subjective, experimental, and classical probabilities. And the final one here is very crucial. You need to know how to calculate the basic probabilities. That's it. All the things we will cover this there. Okay. And here we have the first one. I talk about some notions about the probabilities. The probability experiment or trial is any process with a result determined by chance. Okay. Okay, that is the example for easy to understand here is you have a coin, right? You have a coin, so you toss a coin. Okay. And that's either an experiment with a chance, right? Because you have two results, right? When you toss a coin, so you have two results. Two results here is the head and the tail, right? You have two results, okay? And that is called a probability experiment, okay? When you toss a coin, or you roll the dice, 6-sided dice, okay? For example, the dice like this. Maybe you know. Okay. Okay, when you roll the dice like this, so you have a chance, right? You will receive the result like 1, 2, 3, 4, 5, 6. That's called experiment. So that's the probability experiment. Okay. Okay, the second one here is each individual result that is possible for a probability experiment is an outcome. Okay, so for example here, when I toss a coin, so you will receive two results, right? The result head and tail, right? Head and tail. So head here, so you receive when you toss a coin, so the result head and tail. So this is an outcome. Right, this is an outcome because it's a result of this experiment. Okay, so that is the outcome. The sample space is the set of possible outcomes a given probability experiment. So here, so the result here is a head and tail. So the head and tail are sample space. Right? Is it clear, right? And an event is a subset of outcome from the sample space. Okay, I will talk to you about what is the event here. So for example, the event in this experiment, I want to get the result that is the head. That is the event. Okay. Or okay, I will give you another example for experiment. For example, I had roll a dice. I roll a die. Okay, so you know the dice here. This is the dice. Okay, I roll a die with 6-sided. Okay, 6-sided, and the sample space in this case is 1, 2, 3, 4, 5, 6. This sample space, and each of the result here 1, 2, 3. So it's equal outcome. An outcome. Okay. Okay. An event here. Maybe I will have event here is I want to the result with 6. Okay. For example, something like this. I want to get a result with the point 6. That's in the event. Okay. Or I want to get the result with the odd numbers. Odd number. Okay, so this one should be 1, 3, 5. Okay, so you see that this set is a subset of the sample space. Okay, so that's equal event. Okay, is it clear, guys? Okay, that's all the things about the notion about probabilities. Okay, so I will give you another example about this. I will consider an experiment with a coin toss and then a 6-sided die roll. That means I will toss a coin first, okay, and after that I will roll a 6 dice. Okay, that's 2 processes, right? 2 stages. Okay, the first one is I will toss a coin. The second one here is I will roll a 6-sided, right? Okay, and the question here is list the outcome in the sample space for the experiment. Okay, how to do that? Okay, I will toss a coin first. Okay, the stage 1. I will toss a coin. And the stage 2, I will roll a 6 die. Okay. So the question, list the outcome. The outcome here is any possible result, right? Possible result. So in stage 1, you have two possible results, right? You will have with a head, okay, the result of head, or you get the result is tail, right? You have two possible results, right? Okay. In the stage 2, when you roll a 6 die, you will have 6 results, right? Okay, maybe 1, right? Maybe the result is 1, maybe the result is 2, maybe the result is 3. So maybe this one is head and 2, head and 3, head and 4, head and 5, head and 6, right? The result like this. Or tail and 1, tail and 2, tail and 3, tail and 4, tail and 5, tail and 6. Okay. Okay, that's all the things, right? That's all the possible results in this event, in this in this experiment, right? Is it clear for you? Alright. So that this step here is an outcome. Is okay. Is a sample space. Okay. That's in the first question. The second question here is list the outcomes. Okay, they will ask you list the outcome in the event, not the sample space. In the question A, they ask you list all the outcome in the sample space. So you need to list all the results of this experiment. But the question B here is they just ask you list the outcome in the event, in the specific event. Tossing a tail, then rolling an odd number. Okay. So they want the result here is the tails and the odd number. Okay, so now you will look the sample space. So what is the result that satisfies this event? What is the result that satisfies this event? Okay, first the tail, right? So you look at here. In this column, in this row is not satisfied, right? Because the first state is head, right? So we don't choose this guy, right? Because don't satisfy this condition, right? So we don't show this. They are okay. So this is satisfied as first condition because the result is a tail. So we choose this guy. Okay. Okay. But the second one, the second state, they want the odd number. So we only choose T1, T3, and T5, right? So the event here is T1, T3, and T5. Okay. That's the outcome in the event tossing a tail then rolling an odd number. Okay. Is it clear? Any questions about this? Okay. So that's the example for you to understand the sample space or event. Okay. So you can look at the solution in this slide. Okay. Okay, you can see the sample space here. I provide here, same thing. And the event here, tossing a tail, then rolling an odd number. Okay, so now we will move on to the next examples. Okay, we will go to the next example. Here, we will consider an experiment that I will run a red 6 dial, and after that I will run the blue. It will not like this. I will run both of them, okay, together. Okay, run the red 6 die and blue 6 die. Okay. Okay, I will provide it here like this. Okay, for example like this. Okay, I will run the red and the blue one together. Okay. And the question here is, they will ask you list the outcomes in the sample space and list the outcome in the event the sum of numbers run on the two dice equals 6. Okay, so now I will give you to think about this. Maybe 5 minutes, think about this. Okay, and let me know. Okay, what about the sample space in this case? Okay, think about this. In 3 minutes. Okay, we have this one. I will use the first one, and the second one I use the. Okay, so the sample space here. Okay, let me know what this. So the result here is 1, 2, 3, 4, 5, 6. The result here is 1, 2, 3, 4, 5, 6, and run together. So tell me what is the sample space in this one. Hi.
Approve.
Okay. Okay, anyone have the answer for this question? Please raise your hand. Could you tell me the answer? Hello. Okay, you have an answer?
Would it be like R1, R2, R3, R4?
Yes.
And then B1, B2, B3,
Okay, okay, exactly. Okay, thank you. Taylor, right? I try to remember your names. Okay, I try to remember. If I forget, I hope you don't mind about this. I will try. Okay. So now I will give the sample space here, right? So the result here is okay. I will start with the rest one. Okay, this is one, right? This is one. The result may be one and one. Okay, one and two. This is the red one. Okay, this is the blue one. And one and three. Okay. One, four. Something like this. 1, 5. Okay. 1, 6. On something like this. Okay, I will provide it here. Okay. For example, 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. Okay. And next we will start with 2, right? We will start with 2 and 2, 1, right? And 2, 2, something like this. And you will get the result. Okay. Maybe the sample space here, like this. Okay, you can see in the slide. Okay, it's the 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And similarly, we have 6, 1, 6, 2, 6, 3, something. Okay, and this guy and this guy is different. 6 and 1, and okay, 6 red and 1 color, one blue is different from 6 blue, 1 red. Okay, although it's the same value, but it's different. Okay, that is the sample space in this case. And the question B here is, list the outcomes in the event the sum of the numbers drawn on the 2 dice equals 6. Okay, so the question here is, they want the result of two drawn die is 6. Okay, so now you will look at the sample space. Could you tell me what is the okay? Could you tell me can you determine the event in this case? So we have a sample space here, right? Could you please tell me what is the event? Okay, list outcome in the event the sum of numbers drawn on the 2 dice equals 6. Okay, so choose here. Okay, you Mackenzie, please.
So same like red first would be 1 and 5, 2 and 4, 3 and 3, 4 and 2, and 5 and 1.
Yeah, exactly. Okay, you can. Thank you. So you can see in the sample space here. So you can choose this value 6. So that is the result. That is the outcome that you want to looking for. So here, for example, this guy is 1 and 4, 2 and 4 is 6, right? 1 and 5 is 6, 3 and 3 is 6, and 4 and 2 is 6, 5 and 1 is 6. That's either the outcome that we want to list, right? Okay, the outcome here. That is the outcome we want to list. Okay, you can see here, 1 and 6, 1 and 5, 5 and 1, 2 and 4, 4 and 2, and 3 and 3. Okay, that's the result we want to look for. Okay, any questions so far about this? Okay, and now the problem here is if you have the experiment that have a lot of stage, that have a lot of stages. So in some cases, you will list when you list the outcome, maybe you miss some cases. Okay, that's the mistake you often make in the exam, make in the homework, something like this. So to deal with this problem, so they introduce to you the tree diagram. The tree diagram is used to list the outcome or list the outcome in the experiment, and this is very convenient, okay, for you to do in this case. Okay, how to do that? Okay, I will give you an example for you to understand what is the tree diagram here. Okay, for example, they will ask you 2 coins. Okay, I will give you the beginning example. That's a very simple example. Okay, and you will understand what is the tree diagram here. Tree diagram. So here, the experiment here is 2 coins are tossed, okay, and use the tree diagram to find the sample space. Okay, that's the first one. Okay, we have 2 coins are tossed. That means, okay, that means you have the first space is to the first coin, and the second one you get the second one, second point. So I will give you the result for the stage 1. Okay. You have two cases, right? You have 2 cases. The first one, the result may be the head, and the result of this may be a tail. You have 2 cases in this case. Okay, when you toss a coin, you have a result head or you have a result tail. And stage 2. When you toss a second one, so maybe you will receive 2 cases also. Is it a head or is it a tail? And similarly, in this case, you will also receive 2 cases, also a head and also the tail. So the sample space here is, okay, the sample space here, you will list like this, head and head, so you write HX here. So head and tail, so you write HT here. So tail and head, you write tail TX here. So tail and tail here, you write TT here. So that's in the way you construct the tree diagram. Okay? So you write on the line, draw it on the line, draw it on the line. So HTT. So it's easy for you when you look at the tree diagram. So it's easy for you to determine the sample space. Okay. This is just a simple example. I will give you another complicated example so you will see the convenience of the tree diagram. Okay. This is the tree diagram. So practice here. So I will consider an experiment in which a coin is tossed and then a 6-sided die is drawn. So use the tree diagram to find a sample space. Okay, I will use this experiment here for you. Okay. So the first stage here is a coin is tossed, right? Okay, so I will write stage 1. The coin is tossed. Okay, so we have 2 cases, right? What is the outcome in this state? What is the outcome? What is the result in this case? You please. What's your name, please? Leah. Okay. Okay. Exactly, head and tail. Right, head and tail. Okay, what about stage 2? Stage 2 here is 6-sided die, right? 6-sided die. So what is the result? You will have 6 results in this case. What about this? Okay, you please.
It would be 1 through 6 on each side.
Yeah, it's side 1, 2, 3, 4, 5, 6. What's your name, please?
Caitlin.
Huh?
Caitlin.
Caitlin. Okay. So similarly like this. Okay, you have 1, 2, 3, 4, 5, 6. Right? Is it clear? So now you will make the sample space. Okay, you look at here. So you write on the line H1, H2, H3, H4, H5, H6. Okay. Similarly, T1, T2, T4, T5, T6. Okay. Okay, that is the example about this. So I will give you the practice examples here. So when you finish this, please look at the example 5. Write out the sample space for the given experiment. Okay. I will use the following letter to indicate choice. M for mushroom, A for asparagus, B for bacon, T for turkey, I for Italian, and F for French. Okay, that's either way. And you go to the restaurant, you will choose. You will want to make the salad for dinner, okay, something like that. So you have 2 stages. The first one, you will choose the topping, the mushroom or your asparagus, and also after that you will choose bacon, turkey. And that is the second stage. And the final one, you will choose the following dressing, Italian or French. Okay. So the question here is, write out the sample space in this experiment. Is it clear? Okay. Think about it in a few minutes. Okay. Okay, so you can volunteer, go to on the board to draw the tree diagram for me if you want. So when you finish, you can go on the board. Okay, let me make a comment for some people here. Highly here. Lee. Robert. Bennett. Maybe I mispronounce Bennett here. Abdul Hamid here. Okay, I can. Chama. John Beater. Okay, here. Kylie. Okay, I will. Lee. Madeline Powers, Olivia, Alondra, Matu, Rich, Tyler, okay, Tyler, Alia Smith, okay, Yassi, okay, Sullivan, Thomas. You Thomas, right? Okay. Sriya, Wally, Sriya. Okay. Cameron Waller, Tyler. Okay. So look at the example 5. So how many stages in this case? How many stages in this case? Other 3. Okay. Exactly. So when you draw the pictures, you have three stages. Okay. Any volunteer to go on the board to draw the picture for that? Draw the tree diagram. You please. Arthur, right?
Yeah.
Okay.
We will need to over there.
Yeah, over there. Probably list all the sample space.
Oh. You want me to sample space?
Yeah, exactly, sample space. When you finish the tree diagram, you need to draw the sample space in the last row, okay? Okay, thank you. Okay, very good. Okay. I give you 2 points. Okay. When you go on a complicated problem, I will give you more than point, 1 point. Okay, you can see that. Okay, the first day here, right? You have 2 cases, M and A, and for X here you have 2 cases, B and T, and the third day also I and F. Okay, and here, so you have this is the first day. And this is the second one, and this is the another one. Okay? And see that. And after that, you will list all the outcome here. So M, B, I. So this is the first outcome. And M, B, F. M, B, F, like this, right? It's on the line. Okay. M, B, F here. And M, T, I. M, T, I here. So it's on the line. M, T, F here. Okay, on the line. So you look at. Make it on the line. Okay, don't write MBF like this. Okay, this doesn't make sense, right? Okay, it's on the line. ABI, ABF, ABF here, and ATI, ATF here. Okay, so you have 8 outcomes. 8 outcomes in this case. Is it clear, guys? Okay. That will finish the tree diagram. Okay, so you can look at the handout and practice. Okay, now we go to the second problem we will do today. Okay, you list outcome and you list outcome of the sample space, you list outcome of experiment. So the question is, how do we calculate the probability and which kind of probability we do in this course? So we have three kind of probability. Okay, subjective probability, experimental probability, and classical probability. And how to calculate each kind of probabilities? That is the question. Okay, and now we will go to the definition of the subjective probability. Okay, the subjective probability is simply an educated guess regarding the change that an event will occur. It's in the least precise type of probability. Okay, for example, so it depends on the expert type of this field. So for example, maybe the expert type about weather. So they will guess it's in 90%. It will rain today. This depends on the expert type. So in this case, the normal people like me, so I cannot guess the weather today. I cannot get the probability today, right? So it depends on the expertise. Okay, when we talk about the weather, so we look at the expertise in weather. Okay, so the expertise in weather, they will tell you it's 50%. It will raining today. It will 90% is snowing today. Something like this. Okay, that is called the subjective probability. Okay. And the second one, this is talk about the experimental probability. Okay, experimental probability. Okay, so to calculate this, we will calculate the experimental probability as follows. So the probability of an experiment is calculated by the frequency of the event and over to the number of times an experiment is performed. That is the experiment probability. Okay, sometimes. Okay, and the final one is often used in our course is classical probability. It's very often appear, and it's classical probability. Okay, and it's calculated by the numbers of outcome in the events divided to the numbers of the outcome in the sample space. So to calculate it, the first thing here, you need to evaluate the number of the outcome in the event. To calculate it, you need to determine the outcome in the event. And after that, you determine the number of outcome in the sample space, right? And you make the calculation like this. So you will get the answer. Okay. That's the probabilities, classical probability. Okay. Okay, I will give you an example to understand this. We have type of probability here, so you can see that. Okay. So now you have examples. Okay, the first thing I want you to determine which kind of probability, subjective, experimental, or classical. Okay. So could you tell me what is the kind of probability in the example A? The probability of selecting queen of spades. This is the classical, this is a subjective, or this is experiment. What is this? Abdul Hamid? Is it classical? Exactly. It's classical, right? Okay. And what about B? An economist predicts 20% chance that technology stock will decrease in value over next year. Let's see you, please.
Subjective.
Subjective. Exactly. What's your name, please?
Tarade.
Huh?
Tarade.
Okay. Thomas, right?
Yes.
Okay, exactly, because you cannot guess. Okay, some people, not you, maybe me, I cannot guess. I cannot predict the chance that technology stock will decrease or increase. Okay, because I'm not a specialist in this field. Okay, so I cannot guess this. Okay, so this is the subjective probability. And what about this? What about C? A police officer wishes to know the probability that a driver chosen at random will be driving under the influence of alcohol on Friday night. So he recorded the number of drivers stopped and the number of drivers driving with a blood alcohol level. And after that, when he record and he determined the probability is 3%. So what is this? Are you sure? Yeah, exactly. It is experimental, okay? Because that's the way he do the experiment. That he records the number of drivers. He record that and he make the experiment, okay? And that's the probability, experimental probability. Is it clear? Okay. Okay, here. So you have solution here, so you can look at that. So now we finished the kind of probability. So now we will move on to the next one. How to calculate how we calculate the classical probability. Okay. So you can look at the slide here. So Beck is allergic to peanuts, as a last dinner party. So he want to choose a cheap case. Okay, so you can 10 slice of chocolate, 12 slice of caramel, 12 slice of peanuts, butter chocolate, and 8 slice of strawberry. Okay, and the question here is, what is the probabilities that baked cheesecake contain peanuts? Okay, my bad. Okay, so now we should, when we talk about this, so we need to determine what is the sample space, how many number of outcomes in the sample space, and how many outcomes in the event. The event here, okay. Could you tell me what is the event here? What is the event here? What is the event here? Specific event here. Okay, you please. Okay, the event here is baked cheesecake contain peanuts. Okay, this is the. Okay, your name is Robin, right?
Yeah.
Okay. The event here is baked cheesecake contain peanuts. So when you want to calculate the probability, you need to calculate the number of outcomes in the event, right? And the number of outcomes in the sample space. Okay. So now we will need to list all the outcomes in the sample space. Okay. So what is the number? Okay. Could you tell me what is the number of outcomes in the event? Okay. In the event here is baked cheesecake contain peanuts. Okay, you could tell me what is how many outcomes in this case? How many outcomes? Okay, you? Okay, you please. Okay, how many outcomes in the event? You talk about the sample space, right? Okay. I ask you, how many outcomes in the event? That's I want you to talk to you the result. How many results in the event baked cheesecake contain peanuts? Okay, you please, Taylor.
Maybe 12 over 42.
Yeah, 12 exactly. The number here, the number of outcome here is 12, right? Because peanuts, right? Peanuts. So you look at the result here: 10 slices of chocolate, 12 slices of caramel, 12 slices of peanuts. So 12 slices of peanuts here is the number of the outcome in the event. Baked cheesecake contain peanuts. Is it clear? That is the number of outcome in this event, in this specific event. Okay. Could you tell me the number of outcomes in the sample space? Okay, next. What is the number of sample space? How many numbers of outcome in this case? You please.
42.
Okay. How to do get now? How do you get this?
I added 10 plus 12 plus 12 plus 8.
Okay, exactly. You 45,
42.
42. Okay, exactly. What's your name, please?
Delaney.
Delaney. Okay. Okay. So now you have the number of outcome in the event. In the event here 12. The number of outcome in the sample space is 42. So could you tell me what is the probability of this event? Okay, you please show.
Simplified, it's 2 to the 7.
Okay, you list this one over this one. Okay, exactly. So the probabilities of this event here is over is 12 and 2. So sometimes they ask you simplify this fraction. simplify this. So it should be over 6 over 21. Okay, simplify it, or you make it in the decimal number. Okay. Is it clear? Is this clear? Okay. The second question here is, what is the probability that baked desserts does not contain chocolate? Okay. So to deal with this problem, you need to calculate the number of outcomes in the event. What is the event here? What is the event here? Okay, Tyler.
It's gonna be 32.
Huh? It's a baked dessert does not contain chocolate, right?
Yeah.
It's the event, and you tell me a number, right? The number of outcomes. Okay, how many number?
32 and 42.
22. 22 is the number, right? 22. So how to get the 22?
No, 32.
32. How to get this?
Because it says, what's the probability that baked dessert does not contain chocolate and 10 pieces that contain chocolate?
Okay, exactly.
Oh wait, butter chocolate. Oh wait, so it's 24 actually because it says peanut butter chocolate. So it's okay. Somebody else can answer because I didn't see the same.
Okay. Any question? Any? Okay. You please.
Is it 20 over 42?
20.
20 over 42.
Okay. How to get 20?
Should I add the caramel, the chocolate, and the chocolate?
Okay, exactly. What's your name, please?
JV?
JV. Okay. Okay. Be careful when you do this kind of the problem. Okay. They ask you, the baked dessert does not contain chocolate. Does not contain chocolate. So you see that. So you have the 10 slice of chocolate. So you not choose this one, this guy, right? Not choose this guy. Okay. And 12 slice of caramel. So it's okay. And 12 slice of peanut butter chocolate. So you will not choose this because it contains chocolate here. Okay. And 8 slice of strawberry. So you choose strawberry and you choose caramel. Okay. 12 plus 8 is 20. Okay. So the probability here is 12 is 20 over 42. Okay. Is it clear? Okay. So you can see the answer here. Okay. Sometimes you need to make it simplify this formula. Okay. And sometimes you need to write on the decimal place. It depends on the question. Okay. So you go to the final examples. Okay, one final example. So consider beginning archers who only managed to hit the target 50% of the time. What is the probability that in 3 shots the archer will hit the target? Okay. So in this case, I recommend you use the tree diagram. Okay, so you have this guy. Okay, you have 3 stages, right? You have 3 stages because he will shot 3 times. So the stage 1 is represent for the first shot, and the stage 2 represent for the second shot, and the stage 3 will represent for the third shot. Okay, is it clear? And in the stage 1, they said it's the 50%. Okay, he only get 50% that he will hit the target. Okay, hit the target. So I write this H here, and miss the target. I will write an M here. So he had 2 cases in this case. Hit or miss. Right? Hit or miss. Okay. And in the second one, he also had 2 cases. Hit or miss. Right? Hit or miss. And hit or miss. And the stage 3, he also had 2 cases. Hit or miss. And hit or miss. Okay. So the sample space here is hit. So you can write down here SMH, HM, okay. And SMH, SMM, something like this. And MHH, MHM, and MMHMM. Okay, that is the sample space. So could you tell me what is the probability in this case? So you need to calculate the number of outcome in this event. Okay, this event here is he hit all the targets 3 times, right? Hit the target 3 times. So what is how many number of outcome in this event? How many number of outcome in this event? Anybody tell me? This event here, he hit the target all 3 times. Okay, Chubu, please. 1 over. Any question? Any answer? Okay, you please, Mackenzie.
It'd be 1 over 8.
Exactly. Okay, how to get that?
Because there's 8 total.
Yeah, A is the number of space and 1 is the number of outcome in the event here. We only choose this guy. Okay, so it's only 1 and 8 here, so the probability is 1 over 8. Okay, is it clear? Okay, that will finish. That will finish here. Okay, thank you for attention. If you have any question, you can ask me anytime. Okay, thank you.